online. Again, I did Module 5. John is going to do Module 6. And this is the web lecture for Module 7, Data Summarization. And I'm the instructor, Andrew Jaffe. And so I'd like you guys to sort of listen to these on your own and then work through the exercises. And then we'll go over the exercises tomorrow and answer any questions you have during class. So data summarization. And so here there's several ways of summarizing data, both statistically and via plots. And so today we're just going to review some of the basic statistical summarizations and plotting summarizations. And so just some useful functions you have when you have numeric values. The mean takes the mean of a numeric vector. SD takes the standard deviation of a numeric vector. A median takes the median of X. Quantile displays the sample quantiles of X. The default is minimum, the IQR, and the max. Sorry, range displays the range. And so, for example, if I have a variable X equals C 1, 7, 8, 10, 12, 16, the mean of X, the standard deviation of X. You can look at the range of X. And then also the quantile of X. So here it gives you the min, the max, the interquartile range, which is the 25th and 75th percentiles, and the median. You can also make basic summarization plots. If you plot X and Y, that's a scatter plot of variables X and Y. Note box plot is a box of Y tilde X, and that's a box plot of Y against the levels of X. And so hist is a histogram of X, and density is a kernel density plot of X. For example, if we want to load in a data set, one that comes with it is called cars. Cars consists of just speed and stopping distance of particular cars. It's one of the data sets like Iris or CO2 that comes with R. And note the data were recorded in the 1920s. So for example, if I wanted to say what's the mean speed in this data set, it's 15.4. And so if I want to do a plot, I can do plot cars $speed, cars $dist. And so now where the help file was, you get a plot window. So you sometimes have to rescale it. And so now if I have a variable, let's just call this cars new. I'm just going to repeat new old 25. So now if I want to show a box plot, I could do box plot cars dist by cars new. So that'll give you this is the distance and this is the variable new. And so another way of plotting, which again we'll touch on, you can also just refer to each. You can use this tilde notation as well. You say dist new, and then if you say data equals cars, sorry, that should be box plot. And so you get the same thing. It's just another way where you don't have to use the $sign notation. You can just designate which data frame the variables are relative to. So there's some additional data summarizations on matrices and data frames. There's row means, column means, row sums, col sums. So this takes the mean and sum of either rows or columns respectively. Then summarization plots for data frames and matrices involve map plot, which is a matrix plot or scatter plot of two matrices, or a matrix and a vector. Where pairs gives you the plots pairwise scatter plots of matrices X and Y, going column by column. Feel free to try some of these out, for example, on the Charm City Circulator data set or some of the other data sets available in R. And so, for example, in the Charm City Circulator data set, if we read in the CSV, the reduced one that just has the day, date, orange average, purple average, green average, banner average, and daily. And I just want to say I'm just subsetting it to contain only the days that have an average ridership value. So those are columns 3 to 6. And so if I just do column means of this data frame and then say missing values equal, remove the missing values equals true, and now get the mean daily ridership per line. Then similarly, I could do the row means. I can take the row means of the daily ridership values, removing them, ignoring the missing values, and then just look at the first 6. So in the first 6 days, this was the average ridership across all 4 lines. Summary has a special property on data frames. It gives you a little bit about each of the variables, including its class, and if it's numeric, the interquartile range. It's basically like running quantile on your variable, and then it also gives you how many missing values are in each column. It's a really powerful tool in R. These are things called apply statements. So that involves applying more general functions to the rows or columns of a matrix or data frame beyond the mean and the sum. So the general syntax is apply. You give it your data frame or matrix or an array. You tell it which margin to operate across, and you give it a function that you want to perform on that margin, and then you also give it additional arguments for that function. So for example, x would be an array. The margin is a vector giving the subscripts for which the function will be applied over. Pretty much for a matrix, 1 indicates do everything row by row, and 2 indicates do everything column by column. And you can also give both, although it's typically rare. And the function can be any function to be applied. See the details in the help file. And so instead of using the column means function, again, I've extracted this matrix of the daily ridership values. And so if I just apply to this data frame, to the columns, the mean function, then I pass na.rm equals true, it's going to do column means. So this is basically identical to running the column means function. But again, it's just a different syntax for it. And so similarly, I can do column standard deviations, which is not built into R by default, but is available in add-on packages. And so here I'm applying the standard deviation function to the columns of this matrix or data frame. And similarly, here I'm applying the maxes, so which day had the maximum ridership per line. And so again, it's flexible. It lets you pass any function and apply it to each column of this particular data frame. There's other apply statements. The URL I provided is a good overview to many of them. T-apply is another popular one. That's for table apply. And then we're going to cover list apply for L apply and S apply for simple apply tomorrow. And this URL does give good examples, and it covers some of the perhaps less used examples of apply statements. And so T-apply is useful for summarizing a numerical variable by a factor or a categorical variable. And so again, from the help file, it applies a function to each cell of a ragged array. That is to each non-empty group of values given by a unique combination of the levels of certain factors. And that's sort of a confusing way of describing this. Simply put, you can apply function fun to x within each categorical level of index. So pretty much it's very useful for assessing properties of continuous data by levels of categorical data. So for example, if you want it, we can estimate the highest average daily ridership for each day of the week in one line in the circulator data set. Here I'm saying T-apply. The numerical variable I care about is dat $daily. I want to look by day, and the function I want to apply is max. Again, because there's missing values, I want to say na.rm equals true. So here is the maximum daily ridership for each day of the week in that data set, shown here. We're going to cover T-apply a little bit more in later lectures as well. So I do want to touch briefly on plots, even though we're going to come back to them for an entire module later in the week. So plotting is a very important component of exploratory data analysis. We're going to review some of the more useful and informative plots here. We're going to go over formatting and making the plots look nicer later. And so again, I've taken this cars data set, and so a scatter plot would be plotting cars $speed and cars $dist. And so here you can see that the syntax is x comma y. So the thing you put first is on the x-axis here, and the thing you put second is on the y-axis. So here you can see a positive association between speed and distance. A histogram is another useful way of summarizing numerical data visually. This is a histogram of the daily ridership on the Charm City Circulator line, and so this is just the number of people, and this is the frequency or the counts of how many people fell into that bin. Density plots are a little bit trickier only because you're not allowed to have missing values. So I try to plot the density plot of the daily ridership. I get this error message saying that X contains missing values, but you can use the na.rm equals true command to drop the missing values. And so here, instead of a sort of a more binned histogram, I get a kernel density of the ridership. Box plots are also useful. Again, as I showed you in the very first slide or two, they work by saying what's on the y-axis, tilde, what's the factor or groups on the x-axis, and so that gives you a sense of the distribution of ridership by day. And lastly, matplot just lets you plot columns of a matrix in the same plot in one line. You can change how this looks. You can make them lines. You can change the colors. You can change sort of the structure. But again, we're showing you what it looks like by default. And so this is one of the lines in black with the number 1. This is the second line in red, third line in green, and the fourth line in blue with the number 4. And so again, this is just a very brief introduction to plotting and some basic data summarizations. The exercises covered the apply statements a little bit more, and we're going to come back to those in later lectures. Thanks.